was by Dr. Lois from Griffith University, and the second talk by Dr. Gilbert Price from Queensland University, both from Australia. And this morning, Professor Zodeveld will give the third talk for us in this morning. So, Professor Zodeveld, or GB, I will call you friendly, yeah? Yes. Okay, we would like to address our huge appreciation and deep respect for your time and give the presentation in this webinar. The PaleoTalk in this morning is a part of our joint research between Alberta University, Iowa University, Michigan University, and also Pennsylvania, Florida, Duke University. So it is a really great collaboration with Indonesia and abroad, yeah, and foreign researchers. So I would like to thank you again, GP, for your time to give very valuable research group from our research in Sumatra and Kalimantan. I will invite Dr. Yan Rizal as a part of our research member and also as a head of department to give very short speech, and then continue by I will invite to Dean Faculty, Dr. Melano, to give the speech and then officially open this morning webinar. So please, Dr. Yan Rizal, to give your very short speech, and then followed by Dr. Melano, Dean of Faculty, and also to open this webinar this morning. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hi, GB. Hi, Frank. I would like to say here we have come to our webinar, and thank you very much for your participation for this webinar. But I want to say not in English but in Bahasa Indonesia, because most of them are. I think you understand it, but a little bit Indonesian. Oke, terima kasih pada kesempatan ini saya mengucapkan selamat datang, selamat mendengar pada acara kita ini. Ini adalah rangkaian dari webinar kami dari KK Paleontologi dan Geologi Kuarter. Nah, di sini hasil yang akan disampaikan oleh Profesor John Paul Zodeveld ini merupakan hasil penelitian yang kami lakukan beberapa tahun yang lalu di Ombilin dan di Kalimantan Selatan di daerah Satui. Hasilnya cukup menarik dan sangat berkesan sekali. Mungkin nanti kalau saya jelaskan sekarang mungkin tidak akan bagusnya, nanti bisa dijelaskan oleh Bapak Profesor John GP. Dan marilah kita dengar bersama-sama hasil paparan mereka. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Pak Dekan, please.
Pak Dekan.
Oke, baik. Selamat pagi Bapak Ibu sekalian. Assalamualaikum warahmatullahi wabarakatuh. Hello, good morning everyone. On behalf of Faculty of Earth Science and Technology, I'm pleased to welcome you to today's PaleoTalk by Professor John Paul, or GP, and Frank. The topic is very interesting and also important, as already mentioned by Pak Dr. Yan. Although this is not my area of expertise, but I believe studies of Paleozoics are not just a historic interest, but are essential for unraveling the early history of Indonesia. Such fossils are often the only tool for age control, which is fundamental to our regional geological studies, or provide a reality check for radiometric and other age dating tools. They also provide local paleo environment and regional paleoclimate information. And this together with biogeographic patterns of fauna similarities between tectonic blocks, we'll have to constrain plate tectonic reconstructions. My area of interest is reconstruction of tectonic blocks. So this study is very important, not only for geologists, but for other earth science related experts. And again, I would like to thanks to Prof. John Fall and Prof. Frank for spending your Saturday. I'm not sure your time is also Saturday also, or maybe still Friday.
Yeah.
Okay. And I hope that our research collaboration will continue, as mentioned by Prof. Yahdi Zaim. And I wish you all a very successful PaleoTalk. Again, thank you. And I really hope that these collaborations will continue not only research, but we can go further by sending students also and also others collaborations. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Terima kasih.
Warahmatullahi wabarakatuh. Thank you, Pak Jaim, Pak Ian, and Pak Irwan. Our today presenter is Professor John Paul Zonfeld from Department of Earth and Atmospheric Science, University of Alberta, Canada. Professor Zonfeld has published 110 papers in national and international peer-reviewed journal, 14 peer-reviewed book chapters, numerous with guidebook and industry report. He has also presented approximately 250 oral and poster presentation at conferences. So the talk today is already mentioned by Pak Jaim and Pak Ian, is a result of our multi-collaboration research. And we work on vertebrate paleontology that found in the Eocene and Miocene age sediment from Ombilin, West Sumatra, and also from Eocene Tanjung Formation in Satui, South Kalimantan. And before I hand it to Mr. Zonfeld, let me explain how you can talk to us during the webinar. So if you have any question during the presentation, please just write to the chat, and we will be answering your question at the end of this session. So without further ado, I would like to kick off things off by welcoming our presenter, Professor Zonfeld. Professor Zonfeld, over to you.
Terima kasih. Thank you. I'm just going to go to share screen right here. It's better to go to the, there we go, my PowerPoint, to see this than my basement office here in my home right now. It is 8 o'clock on Friday evening for me. So in a very cold place. I would much prefer to be in Indonesia right now. I have a long, cold winter coming up ahead of me here. So it's only going to get colder now. As you can see, there are many authors on my presentation here today, and this only scratches the surface. There's many people who've contributed. On this list are the primary people who've worked most recently on the fossils here, including a nice group of Indonesians, one Canadian, Americans, Viviana Barreda from Argentina, Daniela Kathoff from Germany. So it's actually a very nice international group of researchers. And I'd like to point out that there's a number of slides that John Block, Professor Block from Florida State University Museum, used in his presentation, in which many of us were co-authors at a conference in the fall. Oh, there we go. And now my slides. Pardon me?
Please make full your screen.
Yes.
Oh, make full my screen?
Yes.
Is it not?
Yeah.
Can you not see it?
So it's not the full
yeah,
screen.
we see it, but not exactly what we expected. You just, maybe you share the wrong screen.
And all the buttons are just beeping now. I'm just going to stop the share for a minute. Oh, hang on. Something goofy happening with the computer. The technology was good a minute ago. Okay. I can't move. I can't stop the share. Oh, there we go. Can you see that?
But it's just a small screen, yeah?
Okay, you're seeing the wrong screen then. I see.
Yeah.
Somehow.
Just stop your screen share and then start again with the right screen.
Yeah, it doesn't want to stop.
It's a hang.
I can't. I can't. None of the buttons work right now. Okay, I'm going to change this in a second here. Oh, there we go. That's now I can see. Okay, I'm going to undo. Plug these. Can you still see me?
Not yet.
Hello?
Not yet.
You can restart the share screen, JP.
Okay, I'm going to go to PowerPoint. Hang on. My apologies for this. Can you hear me?
Yes, sure.
Yes.
I cannot hear you. Can you hear me?
Yes,
Yes.
sure.
I'm going to leave the meeting and come back in.
Oh yeah, sure. No worries. Maaf saudara-saudara, ada sedikit kesalahan teknis. Jadi JP akan kembali lagi sebentar lagi.
Tadi waktu tes technical tadi udah oke ya.
Udah nggak apa-apa, Pak. Sorry that there is a little bit of technical issues and GP will be back in a minute.
Tadi baik-baik saja waktu dites.
Nah ya, tadi waktu technical test tadi oke. Selamat bergabung Pak Rubianto, profesor baru kita. Selamat ya.
Selamat Pak Ruby.
Selamat Pak Ruby.
Peace. Unmute dulu Pak Ruby, nggak kedengeran suaranya.
Oke, terima kasih Bapak-Bapak semua, Ibu-Ibu. Maaf saya baru bisa bergabung sekarang.
Oh, baru
sedang
mulai
di jalan.
trouble.
Iya, GP-nya kemana nih?
Lagi nunggu trouble Pak. Tadi slide
Masalah
presentasinya
teknis.
nggak beres.
Pak Rubianto apa kabar? Sehat-sehat?
Halo. Oh,
Yarmanto
ini
ya?
Pak Yarmanto
My
ya?
apologies. I'm back
Yarmanto ini,
temporarily here.
waduh.
Sorry,
Trying to
please,
fix the
Pak.
problem here.
Teman angkatan ya?
Pak Jaim, please, Pak Zonfred sudah masuk.
Oke. Oke.
Ya.
Are you good, JP? We can restart again?
Can you hear me?
Yeah, sure.
Yes.
Can you see me?
Yeah, sure.
Yes.
I can see
I
you.
can see you clearly.
There we go. Are we there again?
Yeah, you can start.
Okay, I try again. I don't know what happened there. And I still can't. There we go. Very slow is all, I think. So now. Sorry, I had bad internet for a while last week, and then it got good again. So I'm hoping that's not the problem. My
Hopefully.
apologies, everybody. Okay. Hey,
You can start share screen, and
okay. Oh, I'm not on share screen. Okay, let me just go back here to share screen. Sorry, the computer is very slow right now. I'm going to go back here and share screen. And I'll go to desktop. Can you?
Yes, I can see your screen, but
it's
still
blue right now.
You know, yeah.
It just,
Yeah.
I think it's just, there we go. Is that good now?
Yes.
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 Okay.
Okay, you can start now.
Okay.
Yes, my apologies for that. Technology, huh? The joys of living in a Zoom world. So I just wanted to introduce some of the main players in our group here. And of course, what we see in this picture is quite a few people you're familiar with. Aswan up front, Doug Boyer sitting beside Aswan down in the bottom, the front row right here. Peter Wolf, the very top up here, he is our paleobotanist. He makes me look very tiny. I'm of course way off here on the other side of the picture, over here on this side. Jan over here, Pak Zaim over here, Rush Shahan and Greg Gunnell were our two main players. They're the two people who started the research project out here. Greg unfortunately passed away about 3 years ago. Very close friend and colleague, and a wonderful human being. And he was one of my first mentors. Got me into this business when I was 18 years old. I started working with Greg. So, and then John Block right here from Florida State University Museum. This was our 2014 field crew. Let's see. Okay, and for some reason the slides are not advancing again. Okay, let me see what I do here. Let's try this. There we go. Now I understand what I have to do now. This is our crew again. We see Agus Sascario in here in the front, and this is actually during the 2019 field expedition. This was in November and December of last year. One of our main quarries in Sumatera is in the area called Tanasera. And this is Santi. She owns the property in which we worked, and her husband, her daughter were part of our workers out there. We have Joel, one of our drivers on this trip, and of course the rest of the crew. This is Terry Smith and Jason Head, whom were also in the field with us. Terry is a vertebrate paleontologist focusing on some of the mammals. Jason is our snake specialist. He so far has found one good fossil for him, so we won't rub that in too much for him. So, and of course, then this is our crew in Kalimantan, and Jan Rizal joined us on that part of the expedition. We have a large part of the crew from the coal mining company, and of course, in many of these areas, the only chance we have to find fossils are in the areas where we actually have the coal mines. And so it is actually wonderful that they allowed us to be in there. That was an amazing place to do some work. The fossils we're looking at here are Eocene in age for the most part. And we'll talk a little bit about the age dating in just a few minutes. These are maps, of course, that you should be quite familiar with. Most of you are from this area. You are currently sitting in Bandung. Bandung looks a little misplaced to me. It should be a little further to the east on this map right here. It gets shifted when things are getting moved around. Our main areas of research were on Sumatra, Sumatera, and southern Kalimantan, on the very southern coast of Kalimantan. And all of these locations are actually on the western side of what we call Wallace's Line. And Wallace's Line is this dark line that comes up here, up into the Philippines and down through the South China Sea. Wallace was, of course, a contemporary of Charles Darwin's, and he recognized that it actually separates major biotic provinces between the Asian biotic province in northern oceanic Southeast Asia and an Australian biotic province, where the plants and the animals are actually quite different. We believe these lines, these demarcations, are related to movement of the different plates. And in this case right here, it's movement of the Indo-Australian plate. Let me find my cursor right there. Here we go. My cursor right here. Movement of the Indo-Australian plate up into towards the north, towards mainland Southeast Asia, crunching up a lot of oceanic crust in between. And I apologize for the structural geologists among us. I am greatly oversimplifying the issues right here. But of course, we are talking right now primarily about what happened during the Eocene. And so up in this part of the map right in here, during the Eocene, the movement on these different elements. What's important for us as well is to recognize that during this interval, we're looking at fossils from Sumatra up in here, and from Kalimantan over here, but these are actually all part and parcel of one large landmass. So we're looking at animals and plants migrating in from the north for the most part, but there's probably some southern contribution we'll talk about in a few minutes as well. Okay. The reason my cursor and my advancing is kind of funny is because I actually have to click on buttons on one screen and point on one screen, but everything's happening on the other screen. I don't know why they separated like that. During this project, we had a few major questions, and they're listed right here. Was the separation between the Asian biotic province with Laurentian affinities and Australian biotic province with Gondwanan affinities in place with the emergence of the Sunda Shelf Islands during the Paleogene, during the Paleocene, which we don't really work on in this project, Eocene and Oligocene? Or alternatively, was there more of a Gondwanan influence that could be predicated or predicted based on modern biogeographic patterns, or even predictions based on the large ocean barriers in the past? To date, up until this project, terrestrial Paleogene vertebrates from oceanic Southeast Asia were largely unknown, limiting our ability to understand the timing of these patterns, where these animals came from, what's timing, what's their source, and what's their origin. And we've contributed a small amount towards trying to understand that in this project. We're also interested in what the rocks, the fossils, the trace fossils tell us about the environments these animals were actually occurring in. Are these basins fully continental, or were there large marine influences in these basins? And what does that say about the connectivity of the land masses? What does that say about animal migration patterns during this interval? I apologize for the green map right here. The Omblin Basin should be shifted just a little bit northeast of Padang right here, not to the southeast of Padang. Again, things shifted a little bit in the maps. We've done a number of projects here starting in 2012. In 2012, Russ Shahan, Allison Murray, Greg Gunnell joined Zaim and his crew in the Omblin Basin to look for fossils. We looked for fossils in the area on that trip. I was not part of that first trip, in the area of Talawi. And this is when they actually discovered the fossiliferous horizons in around the Tanasira area. The fossils come all solely from the Omblin Basin in the Barisan Mountain Range, which of course runs up the western spine of Sumatera. I gotta go over here, there we go. Our oldest fossils come from the Sankarang Formation in the Omblin Basin, of course. And the fossiliferous succession consists of very, very thin shales, what we refer to as paper shale, organic rich shales. Sometimes we refer to them as oil shales, because these shale successions are incredibly hydrocarbon rich, and they can be processed. They can actually be processed either through drilling and mining, or they can be processed through mining, physically mining the actual shale itself, and essentially baking the oil out of it. There are common interbeds of sharp-based siltstone and sandstone beds, which probably reflect small-scale events, turbidites, transporting fossil material and sediments into the basin. There's a number of horizons that actually have produced fish, plant fossils, some vertebrate fossil material. Here's an example right here of an incredibly well-preserved Bahinia. It's actually on one of the event beds to which we were talking, and so it actually comes out as a nice large fossil. It's actually quite well preserved. You can see the veining preserved within the leaf. You can even see some small boreholes where insects or other invertebrates were actually mining into the leaf. More important for us were the presence of a number of different fish types. This is a large gourami. Gourami are fish that are indigenous to Southeast Asia. They are present now. It's kind of cool to find out that they're actually present in the Eocene of Sumatra as well. This is a animal called Omblinichthys yemeni, named by Zaim Aswan. Allison Murray was the primary author on that paper, and of course, Greg Gunnell and Russ Shahan in 2015. Gourami are interesting fish because they actually say some interesting things about possible environments. They have, of course, like all fish, they have gills, but these fish also have an adapted swim bladder, which has evolved into a rudimentary breathing apparatus as well, almost a precursor to a lung, if you will. And so these fish are actually able to breathe on land. They're actually able to crawl on land and move from body of water to body of water. And so their presence in many cases may indicate we're dealing with oxygen stresses, and the animals themselves may actually have to move from pond to pond. And so this is actually quite an amazing adapted fish. We also find numerous cyprinids. Excuse me. And cyprinids are minnow-like fish. They are typically smaller fish. These ones right here range in size from fingerlings up to about 15 to 20 to 25 centimeters in overall length. They are very, very well preserved. They include a number of new taxa as well, a number of new forms as well. They are interesting fish because they're actually stomachache. They basically eat and digest within their digestive tract without a true stomach in their systems. So very, very interesting fish as well. And we actually have a moderately diverse assemblage from the Sankarang Formation. The Sankarang Formation in this area is clearly Eocene in age. A little higher in the section near the Sankarang Solonto contact, we start to get into true lake margin deposits. We have quite a number of vertebrates. I'll talk about those in a few minutes. Almost everything we find in this succession is disarticulated. Lower down within the Sankarang, most of our fish are articulated. I'll just jump backwards here for a second. I'm going to go backwards to our cyprinids. So most of our fish, like we see in the upper left-hand corner of our shot right here, are articulated with the fins, the tail right here, and the fins still in place. This example right here is starting to disarticulate from a taphonomic standpoint. What's probably happened with the upper right example, there's my cursor right there. So this fish right here, you can see some of the fins themselves have removed themselves. Here's a fragment of the tail, which has moved itself right here. And so this fish is mostly articulated, mostly properly assembled, but some of the material has actually moved away. And so that animal lay on the lake floor. It rotted for a bit, and probably some scavenging went on. Other fish came along, probably other cyprinids came along, and fed on that fish. This is different than the case within the Solonto Formation, where we have essentially no articulated material. All of our material is disarticulated, so we find individual bones, we find vertebrae, we find jaws, we find a fragment of a skull, we find teeth, we find fragments of turtle shell, and a single mammal incisor, which we'll show you in just a few minutes. That fossils, although they're disarticulated, are actually very, very important and tell us an awful lot of what's going on. This is what the outcrop looks like when we're not mining it. It is typically covered. The only reason it's even there is because the locals had actually built a roadway up the hillside in the area right in here. And they were gracious enough to allow us to come in and disrupt their roadway, dig big holes in it, with the provision that we actually rejuvenated the roadway afterwards. And so after a few weeks of work, this is what our roadway looked like. These are two photographs are almost the exact same shot. I am very, very happy that we had Senti's husband working away, digging the hole for us, because us poor Canadians can't dig this deep in the heat. We would probably melt. So it was great to actually have local help for that. We have basically mined that layer about as deep as it's feasible to go without really opening up the hillside. We found a number of interesting fossils in these rocks. Here's a fragment right here showing some monocot plant stems, leaves of grass blades, basically on there. And we found quite a bit of that. The horizon producing the fossils was almost a coaly horizon. It contained an awful lot of organic and plant material. I'll talk more about that. I'll jump backwards into that in a second. I'll also point out then we collected fossil material from the overlying layers right here. This is from a small coal mine about a half an hour's drive away from the Tanasira quarry. This is what we refer to as the NAL mine. We can see in here, we're actually looking at a fully terrigenous succession with lots of channel sandstone successions cutting through, and then individual coal layers that are actually producing the material which they're mining in the area right in here. Jumping a little bit forward in the talk right here, I just want to point out that based on palynology, our Sankarang Solonto Formation contact is actually somewhere in the mid-ish Eocene. We can't place it too precisely, but based on plant migration patterns, it's probably somewhere within the mid-Eocene. So the Sankarang fossils are clearly all middle to lower Eocene. The Solonto fossils, the fish and plant fossils from Tanasira, like I said, are lower to middle Eocene. The fossils from the vertebrates in it says coal mines. It actually should be from the Tanacera locality as well. Those are somewhere right around that Sankarang Solonto contact. They are also mid to upper Eocene in age. And then the fossil plants from the coal mines shown here, plant fragment that I'm holding in the photograph right here. These are clearly still Eocene in age. The polynomorphs that we have here are indicative of a middle to upper Eocene age. And so this pushes the material here back a little bit older than we originally thought. We thought we were actually going to be dealing with Oligocene fossils here, but they're actually Eocene in age. So I'll just move forward this slide right here. Here's an example of some of the plant material right now. This is actually stored in the facility in Bandung, in ITB in Bandung. We have some beautiful fossils there. These include the first macrofossils of the Macadamia family from the Proteaceae. We knew that they should be in Indonesia based on polynomorphs, based on pollen. We'd never found plant fossils before, and now we've actually got some very, very good examples. There's an example right here of a modern leaf right here. This is taken from the Myocum area on the extreme eastern side of Australia, in New South Wales, Australia. Thanks to Koyman for producing that photograph for us. We see Peter Wolf right here from Penn State University. He's our plant fossil specialist. He's done great work for us in identifying these plants, and he's going to do more work. At some point, we will travel to Bandung to spend time prepping out these fossil plants more and understanding these fossil plants more. The plant fossils we found contain some very, very interesting things, possibly the very oldest coconut. Of course, these Proteaceae, as well as a number of other fern and palm fossils. So really quite interesting, quite exciting, but our studies in the plants are still embryonic. There's a lot more work we need to do. Viviana Barreda is our palynologist, and she's actually been able to help us date that. It's actually quite interesting because the fossil material that she's analyzed includes both polynomorphs, which are numbers 1 through 12, and I won't even try and tell you which one's which. I'm not a palynologist. The best I can do when I see pollen is say, hey, look, there's pollen. So I'm going to avoid trying to do that. But what I will point out right here is in photos 13 through 17, we've actually got some dinoflagellates. We've also got some foraminifera linings that are present in there in some of the upper photographs in 15, 18, 19. And so we've actually got some indications of marine influences within the basin itself. And that's actually consistent with other data we have, with some of the trace fossil work, some of the ichnofossils, the evidences of marine invertebrates are occurring within some of the horizons. And so the deposition of our Solonto formation is actually argued to be a lower coastal plain, estuarine flats, and associated with coal marshes in the area. So it's actually quite useful for understanding the environments that we're dealing with. Our succession that we're dealing with right here in terms of overall migration of plants, I won't go through this slide in too much detail. This is based on Bob Morley's work, but basically what we're dealing with right here is the evolving collision of the Afro-Indian flora, the Indian subcontinent, with mainland Southeast Asia, and the first of the polynomorphs, the first of the plant pollen, making it from India into the Indonesian area through wind drift. And that started probably some of the ballpark of 50 million years ago, continuing on until we actually had collision with mainland Asia. Now in this photograph as well, you'll notice that initially we only had pollen moving from India towards Indonesia, but later on we actually start to see pollen migration from east towards west, and eventually we have that western migration during the Oligocene into the Miocene. I won't talk too much about that, as that's not the research that we've done on this trip. Just want to point out then that the interval we're looking at right there is this succession right here. It was seasonal to perihumid. And again, we're looking at an area that is lowland, coastal plains, proximal to a marine influences. Okay, so we talked a little bit about the deposits. We've already talked about Allison Murray. Allison is our fish paleontologist. And again, fish are not my forte. I'm able to actually look at fish. identify the bones, but Allison's able to actually take the individual fish fossils and the isolated elements as well and identify them and come up with an idea on the diversity. And this is actually a beautifully diverse assemblage. I should point out the fish were actually well known prior to this. Back in the late 1800s and very, very early 1900s, an Indonesian Dutch field group had collected fossils from the Omberland Basin before. We're not sure where exactly their quarry was, but it might even be very close to the present quarry that we're dealing with here. This is a short vertical succession through that rock wall right in there. And again, it's important to recognize that most of our fossils are coming from the areas proximal to the lake margin marshes, the Coley horizons, the Carboniferous horizons, where we're finding things. In this succession, we do see fish bone within the limestone beds higher up in the succession once we start getting into Silurian formation proper. It's in that transitional interval in the lowermost Silurian where we see the Coley beds that are actually producing the fossils. And there's one horizon in particular, about a 15 to 20 centimeter thick horizon, that has produced fish, amphibian, crocodile, turtle, snake, mammal fossils. That single layer is responsible for the bulk of the diversity of the fossils that we've collected. Here's an example right here of an urine, probably frog maxilla with teeth. Yes, believe it or not, back in the Eocene, frogs actually had teeth. This is when we actually found that right here, sitting on our porch in our hotel in the town of Sulawesi. Beautiful place to stay. That was my favorite hotel, Zaim, I think, of all the trips we stayed at. I loved that deck where we could work on the fossils, and of course, being the bule that we are, have our evening bintang with that. Trust me, the bintang did not color the interpretation, so it was based solely on the science, of course. We've also found some of the very first turtle fossils, the very first turtle fossils from the Paleogene of Indonesia. There's a variety of turtle fossils that we found. Jason Bork is from Florida, is one of our turtle specialists. This is actually an area that I'm quite comfortable as well. I've done a bunch of turtle work myself over the years. We've also got turtle fossils from mainland Southeast Asia, but never from Indonesia before. We have late Middle Eocene fossils from Myanmar, late Eocene to Oligocene from Thailand. Interestingly, the Eocene turtles that we find are actually very similar to things that we find in Southeast Asia nowadays. We see evidence of soft-shelled turtles. These beautiful, you can see this material right here. This is part of a turtle costal element. Oh, sorry, I'll go backwards there. I'll jump backwards. A turtle costal element right here with that beautiful patterning of that soft-shelled turtle. Soft-shelled turtles are called soft-shell not because their shells are necessarily less bony overall than other turtles. It's that there's actually a softer covering, almost a leather-like covering over top of the individual bone elements of the soft-shelled turtle. The dermal pitting that we see, the presence of the ridges, very similar to the modern extant Asiatic soft-shell, Amida cartilaginea. We've also got geomydids, which are familiar to most of us. They're incredibly widespread turtles in the modern world. They occur here in North America. They even occur here in Canada, believe it or not. These are not snow turtles. They actually occur in the warmer parts of Canada, down in the south, which is not where I am right now, by the way. And they occur, of course, also occur in the old world. So we actually see old world geomydids as well. We have two of them within our succession. One we would argue is more of a semi-terrestrial form based on the carapace shell thickness. Turtles, of course, for those who aren't familiar with this, have a shell top and a shell bottom. The bottom we refer to as the plastron, the top is the carapace. What we're exhibiting right here are all carapace elements. You'll notice on these photographs right here, the lines right here on the outside of the shell, that's actually where this element right here would have sutured to the next bone element. These are basically expanded ribs or bony material over top of what an expanded rib would be. What we're looking over here are the suture lines on the edge of the bone itself, and we're looking at the epidermal sulci. And so there's the bone layer, and then there's actually a layer over top, like you can see in this turtle right here, which is more like fingernail over top. And so these lines right here on this turtle, and these lines right here are epidermal sulci, we refer to them as. And that's what we're seeing on this bone. This is a sulcus right here, a sulcal line right here. And those are these exact lines right here in between the individual epidermal layer. Scutes, we refer to those as. We've also got tortoise material, land tortoise material preserved in here. You can see the really thick shell with these growth lines of the epidermal layer preserved on the outside of the bone. It's not a huge taxon. It's a moderate-sized animal. We're probably looking at an animal that would have weighed somewhere in the ballpark of 5 to 8 kilograms and been somewhere in the ballpark of the size of a large coconut. Not a huge animal, but certainly not a small animal either. And probably our most diverse assemblage are the crocodiloids. We've got a number of different things. We've got a number of partial mandibles. There's one shown here in the bottom. There's my cursor right there. There we go. You can see the jawbone element right here, the bulge where the teeth would occur. There's actually a tooth alveolus right here as well. We have a number of postcrania. This is part of a vertebral centrum. There's a number of vertebrae that occur within the succession. Teeth, of course, are self-explanatory. And crocodilians, just
Sorry,
like...
JP,
Oh,
to
hello?
interrupt you for a bit. We can't see your cursor.
Oh, you can't see my cursor.
Yes.
There it is. Okay, there we go. And so the osteoderms, which we have right here, are bone elements in the skin. So crocodiles have bone elements in their skin as well. They're not a continuous shell like a turtle would have, but they certainly occur there, and they actually add to the rigidity. Crocodiles tend to be quite combative. They fight with each other, bite with each other. It's quite a common element. And so this is actually bone armor, protecting themselves, for the most part, from each other. And the upper left over here, we actually have part of a partial brain case, which I'll show as well. The osteoderms contain both rectangular as well as sharply keeled osteoderms. There are a number that are actually more rounded in overall shape. Overall, we're looking at this and we're seeing evidence of several different crocodilian taxa. I'd argue we're probably looking at 4 or 5 taxa. I'll jump to the next slide right here. Here's the brain case right here showing some of the different parts. I won't point out all the parts right here, but it's quite interesting. A number of the characteristics indicate to us that we're looking at a part of a crocodilian skull. The narrow parietal between the suporal fenestrae, lateral carotid foramen, dorsal to posterior lateral expression of the basis sphenoid on the brain case itself. I won't point out all these different things right here. The point is right here is that we're absolutely convinced this is actually a crocodilian skull fragment right here. Chris Brochu is quite excited by it and thinks he may actually be able to name a new taxon based solely on this material right here. So, so we're very comfortable with this as a crocodilian. The teeth themselves are actually. Oh, hello.
Oh, since your cursor is too small and it's dark and the background is dark, can you just click right click and then choose the laser pointer instead?
I'm scared to try and do that right now because I'm going to mess everything up. Right clicking's
okay.
not working right now.
Right. That's all right.
So,
then. Thank you.
Yeah, I would do that otherwise, but yeah. So it
Okay,
won't. There won't be
just
too many
one
black
thing,
slides. Yeah.
Yeah.
So. Here we go. So I'll make sure I point out in the white as much as possible here. So here's, oh, of course, I don't know why it just jumped right there. There we go, backwards here again. We've got several different teeth shapes in the end. By the way, part of the reason why you probably can't see my cursor all the time is I had the bad habit of pointing on the wrong screen. The screen that you're seeing is my big screen. The screen that I have to point on is my tiny screen, which I don't know why it's doing that either. It's a weird communication problem between Zoom and PowerPoint on a Mac computer, I guess here. So never had this issue before. So always new issues, right? We've got several different teeth types. We have the upper left corner there. We had that slender, low-crowned tooth. We've got a fat, more bulbous tooth shape that we found this past. Oops, I'll jump backwards here again. We found this past November when we were in Tanasira. We had this big long tooth right here. It's called a xiphidont tooth. It is serrated, which is actually quite unusual. What's interesting is we start to compare these teeth to different taxa. We've got teeth that are more consistent with Laurasian teeth, as well as teeth that are more consistent with Australasian teeth within these crocodilians, which is then quite interesting. Of course, crocodilians are aquatic, and so they actually would have a chance, even without a landmass connection, they would have a chance to actually make it from island to island, migrate their way up into southern Sunda province, whereas other things such as mammals would be very, very unlikely to be able to do so. Down, there we go. We've got a number of other interesting fossils, and I'll point out a few of these. This right here is actually a pre-cloacal vertebra from a snake. It's our only snake fossil or definitive snake fossil to date. There are a number of other fossils that are awaiting prep that may also be snake as well. They're actually quite interesting. The reason we know that snake fossils are snake fossils is simply that they actually do have more of these processes on their vertebrae than a reptile or a mammal or a amphibian would actually have. So the vertebrae are actually quite unique and quite characteristic. They are incredibly diagnostic, not just in terms of the overall grouping of fossils down to snake, but in fact, we can tell that this is actually an anniloid snake. And this is actually the first example of a fossil anniloid snake from this part of Southeast Asia, from any part of Southeast Asia to my knowledge. Here's an example of a modern one right here, Cylindrophus rufus. And our ancient one right here, the snake right here, is actually probably going to be a type specimen of a new organism. Sorry, on the right-hand side right here, I should point out, these are actually modern vertebrae right here of a modern anniloid. And we're looking at right here on the left is our fossil anniloid vertebra. I know the fossil looks a little less well preserved, but there's actually enough there for us to actually identify it down to the family, and we'll probably actually be able to come up with a definitive characteristics for a new genus of fossil snake here. Jason Head is at Cambridge University is our snake man right here, and he is incredibly excited for this. This is actually quite unique. As I mentioned, it is the oldest example of this type of snake in Southeast Asia. It's the oldest, it's the only example of an anniloid from the Paleogene of Southeast Asia. These were fossorial snakes. They are fossorial snakes. They have wet forest habitats. It's quite interesting. Regardless of the distribution of these snakes, it really is an important fossil for us. It tells us an awful lot about what's going on right here. What's interesting, of course, is combining some of our vertebrate data with the plant data we have shows evidence here that we're actually looking at co-shared migration of both plants and animals within the study area from northwest down towards southeast into the Sunda province. There we go. This is John Block, and this is John Block looking incredibly excited. This is John Block here in 2014 because he found our sole mammal fossil. There it is right there in a piece of carbonaceous shale to coal. One tiny tooth right there. This tooth has been removed from its matrix right there, and this is a photograph right here, a SEM photograph right there. It is a rodent incisor. Now, rodent incisors are not the most diagnostic fossils in the world, but in fact, we're actually able to say a number of different things about it. The curvature, the wear on the fossil suggests that it's actually a lower incisor. We dissected the tooth so we could actually understand the enamel better, which tells us an awful lot about taxonomy. There we go. And Daniela Kelthoff from the Swedish Museum of Natural History has done the work for us on this right here. And she's identified that we're actually looking at a tooth with inner portion with Hunter-Schrager bands, a outer portion with radial enamel, in which the prisms run parallel to each other. It's a unique microstructure to the tooth enamel, which indicates that it's actually characteristic of living hystrognaths, tenodactylids, rodents. Now, I just use a couple of words there that almost nobody will be familiar with. So let's just jump forward right here. These are the animals we're looking at here. Rat squirrels, gundys, some porcupines are the animals that actually have these types of teeth. We're not sure which one it was, but there's a number of extant rodent groups within the Senohistrica that contain tooth enamel that looks like that. I, of course, am fond of porcupines, so I'm a strong proponent for that. But in reality, it probably actually is either a lock rat or a gundy, but it's an early example of that. The extant distribution of the lock rats is Southeast Asia. We see species from the Oligocene to Miocene to the modern of India, Thailand, China. So they're actually moderately common animals. Of course, the comb rats, the gundys, the comb rats occur primarily within northern Africa nowadays, but during the Eocene of Asia, they're present. They occur in the Pleistocene of Asia. I'm not aware of any that actually occur later than that, but certainly they had a wider range at one point. Porcupines are everywhere. Porcupines, mole rats, guinea pigs, capybaras. The Hystrognathidae is one of the more common and more widespread groupings of cenohystric rodents in the world today. They are incredibly common, incredibly widespread, and incredibly important. There's another project I'm working on in Vietnam where the entire fossil assemblage of vertebrates were brought into the cave we were looking at by porcupines, which is one of the reasons why I'm so fond of them. They're awesome fossil accumulators in the end. So this map shows possible migration routes of the rodents themselves. During the middle of the late Eocene, there's been a number of places where we have fossil material, number of areas where we actually see the same enamel condition that we actually have in the fossil tooth in which we have. It's a rather incomplete fossil record, but the fossil evidence does show that the radiation had a larger paleogeographic dimension than previous known. And this fossil itself is very, very important. It is the only fossil that occurs down in Indonesia, the only mammal fossil from the Paleogene, and the only fossil of this rodent grouping within this area. Okay. Also want to mention some of the fossils that we find that are more focused on some of the work that I've done with Azwan and Zaim and Jan and Agus and others in the project right here. I'm the sedimentary geologist, stratigrapher in the more recent iterations of the project. Since 2014, I've been working on these projects with these guys. I tend to work on that interface between the paleontological, sedimentological, stratigraphic realm. And so, of course, I'm interested in fossil behavior, footprints, burrows, and what it tells us about environment, what it tells us about the nature of the sediments we're looking at. Zaim is looking at a bedding plane right in here, which was actually covered with numerous examples of fossil bird footprints. So these are actually a trace fossil we call Avipeda. It is from a small shorebird. You can see it's a three-toed shorebird right here. So toes 2, 3, and 4. The fourth toe, which is present sometimes, the helix, is not present on these birds right in here. All of these examples on this bedding plane right here are from one taxon. What's interesting here, looking at this right here, I'll just throw that backwards here again. What's interesting on this particular illustration is we also see a number of these types of traces right here. You see that circle right here, connected by a bar right here to another circle over in here. This is actually a cross-section through a trace fossil called Diplocroterion. And Diplocroterion in these cases are made by either small annelids or small arthropods. In this case right here, I believe they're actually made by small annelids, worms, if you will. You'll see another burrow right here. You can see the circle right here with another kind of squiggle associated with it right there. This is actually part of a vertical tube, a dwelling trace of a small annelid as well. Another example up in here. So you see quite a number of these. If we look at the pattern of bird footprints right here, you can see one right here. Here's the toes 2 and 4 with toe 3 right here, but shifted over to here. So there's shifting going on, and he's stepping right on top of this worm burrow right here. The orientation is all over the place. This is evidence right here of an animal that's actually feeding. It's browsing, it's grazing, it's looking for food resources on this sand bedding plane. Okay, there we go. Next slide. Another example, in this case right here, we're looking at a different trace right here. This is a holotype of trace fossil called Aquatilivipes wallacei. It is another important trace within the area right here. Again, three-toed, but now it's less curved. We actually see that the toe 2 bends outwards in a very, very weird pattern, unusual in terms of traces. And we see a number of other trace fossils as well. Again, we see that dumbbell shape right here of the paired vertical shafts. The round circles are the vertical shafts of the dwelling trace of the burrow. This line in between connects them in almost a dumbbell or barbell shape. And that's actually all part of one trace fossil right there called Diplocroterion. Diplocroterion occurs solely within marine to marginal marine environments. You can also see this path right here, this pattern right here. This is actually a drag trace. And so you can see little white dots along the edges right here. Those are footprints. In this case right here, we're looking at a hermit crab crawling trace. something called Cenobichnus. Cenobichnus is where the hermit crab crawled along, dragging its shell, dragging the gastropod shell that it's occupying, and moving along the bedding plane right here. So we're looking at quite a diverse and dynamic fauna here. We're looking at trace fossils that indicate in-faunal suspension feeding, in-faunal deposit feeding, hermit crabs crawling, birds grazing. I'm pretty comfortable calling this a intertidal flat succession right here. So in this part of the Ombulan Basin, we're looking at, certainly looking at marine influences, and that would have occurred right in the middle to later Eocene, late Eocene, maybe even early Oligocene at this point. Move my slide forward here. There we go. Another bedding plane closely associated. In this case right here, we can see 3 traces of a bird walking along. And what's very, very interesting in this trace right here, this Avipeda, is we see 3 very, very different preservations. This first one right here, all we see is kind of a vague, poor definition right there. So where a bird was stepping on top of a algal mat. It just didn't dig in very far. We see 3 more traces right in here. In this case right here, that bird dug its claw, penetrated through that algal mat, that bacterial mat actually, and left the actual claw prints as well. And in this one as well, we're seeing it right here. We think what actually happened right here is the bird was walking along, and at this point right here, it dug its toes in as it took off, as it flew away. So they're actually preserving a story of the actual fossil behavior, which is actually quite cool when you think about that. A day in the life of a bird. So we talked about the Ombulan Basin right here. I want to jump forward now. According to my notes, I should be at least halfway through my talk, and hey, I'm actually vaguely on time for a change. As Zaim knows, I can talk and talk forever. So it's very, very rare that I'm actually even vaguely close to being on time with a presentation. I see you laughing at me there, Aswan. So anyway, I want to jump over across the Java Sea to the Awesome Basin. And the Awesome Basin is a small sub-basin south of the Maratus Mountains, the Maratus complex. I'll show it actually on the upper map right here. We see a geological map. The Awesome Basin is a sub-basin of the Burrito Basin. In reality, we should probably refer to this as the Greater Burrito Basin. The Maratus complex did not rise until the Miocene, and so it postdates deposition. During deposition, this was all part of one large basin that we should refer to as the Proto-Burrito or Early Burrito Basin. These maps right here come from a paper written by Duncan Vitz, part of his PhD dissertation, written with some of his advisors. It's a beautiful piece of work, a really, really well written PhD dissertation. I would have been proud to actually have called that my student's work. I believe that was done at one of the Australian universities, but don't quote me on that. I'm not 100% certain. The work we've done in the Tanjung Formation in Kalimantan are through a number of connections that Jan Rizal had with coal mining companies. And again, I'd like to really state that we really appreciate the work that the coal mine companies have done in allowing us to actually access these sites. Without these sites, we'd be wandering around in jungle, in rainforest, finding essentially no outcrop whatsoever. So it's actually really, really quite pleasant to them to allow us, the inconvenience to them of allowing us to come into these areas and work on these sites. All of our sites occur within one main mine complex in the area, and I'll talk about that in just a couple of minutes here. Here's the pit right here. This is actually a jointly operated pit between Arutmin and PT Bayan Resources. The company names may have changed, so correct me, Jan, if I'm wrong about the company names right in there. They jointly operate this pit. It's a huge pit. And of course, I jumped forward again. I don't know how that happens. It's a beautiful place to work. Now, I want to point out a couple things on this photograph. You can see my cursor right here. It's actually quite apparent on this slide right now. You can see this line between the red tan right here and the green line right here. Keep that line in mind. You see right along right here. It kind of dashes over in here. It kind of goes up in here. The green line separates out 2 members of the Tanjung Formation. The Tambak member and the Pagat member. I'm interested in both units right here. We're going to talk about the fossils from the lower succession. Look at it this way. The red tan beds down at the bottom are non-marine to marginal marine in nature. The green beds, the gray beds on the top right here, we're looking like a bird looking down in the mine. These are sitting on top. They're shallower in the mine. These beds over in here are the fully marine beds right in here. They contain shale, foraminiferal packstone, foraminiferal grainstone. They are clearly fully marine in their nature. And we'll talk about those in just a few minutes. This is a map taken from some of the work that the coal miners did. They provided to us a couple of maps showing the succession that we're actually interested in. All of our units that we're looking at are from the Tanjung Formation, and they're all Eocene in age. We know that because although we haven't gotten any age dating in the lower part of the unit, we have good foraminiferal dating in the upper part, and all of our forams are latest Eocene in overall age. We can see where the mine is right in there. We stayed in a couple of mine-provided accommodation, both on the coast and in the interior in different trips. Here's a vertical succession again. We're looking at the Tambak member here and the Pagat member. And again, keep in mind then, the Tambak member, this member over here, the middle member right here, is these red beds right here, these striped beds down in here. The lighter color right here is actually a sandy succession. We see interbedded coal and siltstone, very fine sandstone in the succession right here. And above here, we actually have a marine flooding surface and get into the fully marine succession there. And there's John Block looking quite excited because he's actually found some fossil plant material in these rocks. These beds, we've only actually ever had a chance to spend a few days on 2 different trips in these beds, but they've been productive for the amount of time, amount of effort we put in so far. So I'm quite excited to go back and relook at these rocks to try and actually assess the fossil content of these rocks. We've not told the full story here yet. We have a lot of work to do. I'll also point out that this is actually based on Duncan Witt's work within the modern Burrito Basin. So the other side of the Moratis Mountains, this is actually based on that. I would argue that the age dates he has right here, the Pagat member in our area is entirely so far Eocene in age. We've yet to find any evidence of Oligocene deposition. I have some new samples that have been sent out to the foram specialists, so maybe we'll actually find that the upper part in our basin is also Oligocene, but right now, all of the Pagat member fossils we found have been Eocene in age as well. And so today's story really is an Eocene story. There's a paleogeographic map from Duncan Witt's thesis. He adapted this from Hall's earlier work in 2008. They are beautiful maps, and I actually have no reason to doubt their veracity. They're actually quite good, quite useful. And we're looking at an area right in here. And in fact, actually, if I go to my own slide right there, jumping in, we're looking at that area right in there. So during the Tambak deposition, we're looking at an estuarine to deltaic complex with coastal marshes, marine-influenced coal basin. Again, just like we saw in Sumatera, we're looking at a marine-influenced coal basin in the study area here. There we go. Here's a vertical succession right here. Looking at beds in the bottom in here, we can see these beds in here contain overbank deposits, a small part of a crevasse splay sandstone right in here, paleosols above and below that, very, very poorly mature paleosols, preserving significant primary depositional structures, but also containing numerous root traces and some small scale evidence of pedogenic or soil forming alteration, what we refer to as pedogenic slickensides, PEDs in there. We see a marine flooding surface at this contact right in here. And now we're actually into an estuary to estuarine mouth succession. We can see in here flazer bedded, lenticular bedded sandstone successions. I'm going to zoom in on some of this in a few minutes because I'm quite interested in those beds. The very top right in here, we go back into coastal plain. So, oops, didn't mean to jump forward yet. Sorry about that. So look at this succession right in here as a flooding surface. At this point right here, we had a sudden backstep of our coast. The sea invaded the interior. And so we have a flooding surface at that blue contact right in there. But on top of this right here, we're dumping sediment into our basin faster than we're creating accommodation space. And so our shoreline is actually migrating back out into our depositional basin. And we actually wind up with coastal plain and alluvial floodplain material in here with a basal coal succession in here. That's one of our mined coals. I can't remember which coal that is. That might be what they call the S7 coal within the mine here. Zooming in on that, this chunk of rock became quite important to me. Number of different features that you can see on this This photograph, it's actually quite cool. It's heterolithic. Lots of different sediment types within this photograph right here. We see some mudstone in there. Look at those darker beds in the bottom of this photograph right in here. You can see down in the bottom in here, some really dark beds in there. You see interbedded light color and dark color beds in the bottom and higher up as well. Higher up in the succession, we see lots of more mundane looking beds, less stripy looking in overall appearance, but lots of these black dots sticking through it right there. And all those black dots are actually root traces, rhizoliths. Paleontologists will never ever use one small word where 3 or 4 big ones are just as good. So instead of roots, we're going to call them rhizoliths instead. Every discipline has to have its jargon, right? What we're looking at here is a depositional setting that's dynamic. There are times where we're looking at quiescent deposition. Look at the laminated black sediments in the bottom right here. We're looking at deposition primarily out of suspension in a succession. You can see these white circles that are actually penetrating through it. Those are burrows coming down from the overlying beds, piping sediment down into the underlying layers. Higher up, we start to see lots of individual trace fossils cutting through the beds. You can see that the beds themselves look almost chattery. That's where individual burrows are penetrating through. I'll show some examples of those in a second. As well, we see lots of lenticular beds in here, ripples. You can see this bed right here, thicker and thinner, thicker and thinner. We see evidence of wave ripples. We see evidence of current ripples on these beds. So lots of different things going on, consistent with changing tides, alternating current patterns, shifting wind patterns on these successions. And then, of course, we actually see bird tracks as well. So back to bird tracks. And this bird track story is actually really quite cool. A lot of different things going on. You see where my blue arrow is right here? That's not primary. I put that there myself. This horizon right here is actually where we have one of our better bird track horizons within these rock beds. There's several different horizons that produce the bird tracks. I'd like to point a few of those out to you. But before I do that, I'll go back again to our overall vertical succession. Here's our, it was our S7 coal. That was our S7 coal that we were looking at. That's that coal right there. That's one of the, oops, jumping forward again, wrong. One of our primary mined coal beds right here. The S6 coal higher up right here. I think it's the X6B coal. That's internal mine terminology. Suffice it to say that what we're looking at right here are a number of horizons capped by these coal successions that are quite laterally extensive throughout the mine. That's why this hole is here. And this coal right here is one of the more important coals for our succession. And of course, lower down in the succession, we also have other coal horizons that become important as well. Basically, they don't dig a lot deeper than just below where I'm standing here, not a huge amount deeper in the succession. You can see in here that this pattern I have right here, this is my indication for pedogenic siliconsides, or what people refer to as PEDs. Think about, I keep hitting the wrong thing and jumping forward there. Think about what happens when soil's wet and dry. They expand and they contract. Clay penetrates into small fractures. The clay itself, when it gets wet, expands and it contracts when it dries out. It moves against itself. It's almost like a small scale fault gouge with the wetting and drying and shifting of the soil. And you wind up with these slickensides or slip surfaces within the soil. None of them go anywhere. They're not extensive, but they're important. They actually indicate root plant alteration of our soil material, soil forming alteration of our soil material. And of course, root traces help with that argument as well. We get into a cross-bedded sandstone at the bottom part of that succession, and then into our lenticular beds. And it's the top part of this succession, so marine flooding surface down in here, and then going back into non-marine back above the succession. This is where we have a beautiful, diverse accumulation of different trace fossils. Things that actually prove that we actually had a lot of different life within these beds right here. Dynamic depositional conditions, marine, non-marine, both. Tides coming in, tides going out. Really cool story of co-association with different types of organisms. Now, I love this particular bedding plane right here. At first, when you look at it, it's hard to see things, but stare at it for a while, and I have. I've blown this up, by the way, as one. So I actually have a photograph of this that is 2 meters by 1.5 meters on my wall in my office. So I could actually really focus and really study where the traces are in here. But you can see right here, bird track moving along right in here. There he is. You can see walking along up that way. You can see a different bird walk down through here. 1, 2, 3. There's probably a fourth that's kind of broken, spalled off right in there. There's another trackway over in here. I'll zoom in a little bit on that. Another one over in there. There's at least 5 or 6 different bird trackways on there, as well as you can see, lots of these circular features, other small horizontal lines and whatever else. And I'll zoom in on those all in just a second. Here's a good example right in here again. You can see right here another trackway, our left 1, right 1, left 2, right 2, left 3. For trackway, what I refer to, this is my own terminology, trackway 2-2. They're all traced out right here. And again, what we're seeing here are lots of evidences. Our trackway L3 right here, that's this particular photograph right here, is this trackway right here. In this case right here, we can see toe 1 back here, 2, 3, 4. 1's barely preserved back here. The helix is barely preserved with toes 2, 3, and 4 again. This thing right here is a invertebrate trace fossil, bird stepping on. We can see the bird shifted its toes a bunch back and forth. These are animals, again, that are hunting for food, looking for food. We see a lot of that on these bedding plains. Now, some of these traces are incredibly well defined. Other of them are more vague and less well defined, much more difficult to see. And I'll talk about why that is in just a second here. Here's that same block we saw before. And again, I've got these bird traces pecked out on here. And the individual trackways, this is my block number 1 right here with trackway T1-1, T1-2 to T1-7. So 7 different birds walked along that bedding plane, and actually 8. I haven't got drawn on here. Another cool print by itself. You see that thing right there? It's unrelated to the other birds. I'll point out that in just a second on another sketch. So just give me a second right there. But what I want to point out here is you'll notice some of those traces were really well defined. Some of them actually are connected by lines. It's a toe drag mark. I'll zoom in on that in just a minute as well. This case right here, we can see a bird that actually has evidence of webbing in its toes, migrating along right here. And then we start to see the drag marks as the animal's moving along. Right about here, the animal walked across a tidal flat, and actually right about here, it actually walked into a puddle on the surface right there. That's where that drag marks is going on right there. These birds weren't all present at the same time. These are sequential. They overprint each other. They may have been separated by minutes to hours, but I would argue not days to months, because of course it's one bedding plane within an intertidal succession. This bedding plane is underwater part of the day and underwater part of the day, and there's always new sediment being deposited. So there's actually a very short window in which these animals could have been there. Were they all present at the same time? No, but like I said, we're looking at separation of minutes to hours, not days or weeks or months. Here, the same box right here, it's drawn in right here, is blown up. And so I'm going to actually blow up this whole trackway right here with a total of, what is that? 4, 5, 6, 7, 8, 9, 10, 11, 12 footprints. It's actually quite cool. You can see initially we're dragging our toe along here. We're shifting back and forth. We see stutter marks in there where the animal footprint overprints by another print right there. So we actually see very, very closely spaced prints. Sometimes the animal kind of jumped a little bit. It's feeding, it's looking for food, it's shifting. This is clearly a feeding trace. All of these are actually feeding traces. The animal's chasing after food. Zooming in on these 4 trackways right in here, we start to see lots of different invertebrate markings in here. All these little lines in here are where somebody's beak was moving back and forth along that bedding plane, looking for food. Very dynamic story of shorebird feeding along this bedding plane right here. Here's a blow up of part of that right here. You can see again then, really well defined. Toes 2, 3, 4 on this bird right here, a little bit less defined right here, and a big drag mark connecting these toes all the way along. See that big line right in there? That's the beak. Beak's going along, swishing through the sediment, looking for food. The animal's moving its beak through the shallow water and the shallow sediment until it actually hits something that is actually not what it expected. Hey, cool, dinner. Off we go. That's great right there. You can also see lots of these black lines. Those are actually plant debris lying on the bedding plane. You can see this particular trace right here with a circle, what we refer to as the causative burrow, and then all these growth lines around it. That's where the invertebrate shifted its burrow around. What's cool is we often see these types of burrows around on the edge of a root trace. And so the animal is actually mining the organics in the root. The invertebrate is mining the plant roots, and the birds are mining the invertebrates. It's a wormy world out there. Some more examples, again, showing some of the same types of things, lots of plant material on the bedding planes. And you'll see we actually have lots of different morphology in there. You know, here this bird has 4 preserved toes. This one right here has a drag mark from the first toe, connecting to the back of the next foot right there. So lots of different types of walking traces, wandering traces. The image on the left side right here shows some of the different morphologies of bird footprints we found here. This particular trace right here doesn't have a name. It's from some type of corvid. Here in Canada, we would call them crows or ravens. And you have corvids in Indonesia as well, modern corvids in Indonesia as well. We have this, I'm not even gonna try and pronounce that one, Ludocarda porticus. I can never quite get that one right. I speak too fast to pronounce that one correctly. It's a large footprint with a webbing within it, probably a heron print, some type of heron or crane moving along that bedding plane. Probably another crane right in here that's actually moving along a bedding plane as well. Some cranes, by the way, have mildly webbed feet, small parts of webbing, not fully webbed, but small basal webbing up towards the back of the toes. Other herons and cranes do not. We have Aquatilivipes, we have Ardeapeta, we have Avidactylia, Avipeda, and of course the other trends. We have at least a dozen different types of birds feeding on these bedding planes. They're herons, they're sandpipers, plovids, corvids, curlews. They're all shorebirds. We have a ton of different shorebirds on these bedding planes. The invertebrate traces show a mix of infaunal suspension feeders, deposit feeders. You see these Ctenidium right here, this thing right here on the rock. You can see it right there. You can see those growth lines in there where the animals process feeding the sediment. The sediment goes in the mouth over here, comes out of the pooper end over there. So it's defecating here, eating over on this end of the trace fossil right there. So tons of different traces moving along these bedding planes, feeding on the amazing organics that occur in intertidal flat sediment. And that is definitely what we're looking at right here. There is no question in my mind that we're looking at a intertidal flat on this succession. It's cool because, of course, Indonesia is an absolutely crucial spot worldwide for so many different things. Indonesia is the heart and most of the coral triangle. It is the home to 80% of the world's coral species. That doesn't really matter for the current story, but what does matter is it's also part of the East Asian, Australasian flyover area. Every year, birds migrate from Siberia down to Australia, even further south, down to New Zealand, down to Antarctica, and back and forth. We have major migration routes of birds, and it's a stopover area feeding every year on tidal flats in modern Indonesia. They feed and feed and feed and gain the energy it takes to actually make it those thousands of kilometers back and forth. The mine we're looking at in South Kalimantan, the Satui mine, the Wahana pit, was also part of that flyover. We're looking at probably a seasonal stopover for shorebirds feeding on the bedding planes. Really, really quite cool. Really quite a cool story. Cool to see that preserved in the rock record. Jumping forward here. We also have, of course, fully non-marine plants. This is a set of roots, kind of fun on a bedding plane. It's right beneath that S7 coal where it was peeled off in a different pit, the next pit over from the Hanuman pit. And this is actually, we're looking for fossils on the surface, and this is one of the very few things I saw that day. Looking for fossils in these areas is long periods of absolute boredom and tiny periods of sheer excitement when you find the fossils. This day was one of those days where we found no real fossils. So I took pictures of root traces here instead. Kind of cool to see the roots on the bedding plane right there. But no good fossils. But other days we find amazing plant fossils. And so there's actually a number of plant fossils that have been collected from the Hanuman pit, field prepped, and are currently awaiting study at the ITB in Bandung. Peter Wolf will sometime in the next year or two fly out with me, and we will impose on Azwan and Zaim and Jan and make them go out for lunches with us and argue paleontology and have some good times trying to understand these fossils better. But this part of the of our study has not yet been done. There's a really exciting story here though. So some more plant fossils right here. These are really cool. These are actually large fossil fruits that were collected as well. Really quite neat fossils. No name for them right now, but of course Indonesia is home for a stunning variety of fruits, some which I love, rambutan and sirsak and you name it, I love them. Some in which I'm less fond. I am not a fan of durian. And that's not a fossil durian, although it has a roughly similar appearance. In a few days worth of collecting as well, we collect a number of vertebrate material here. Again, we found turtles. Again, we found fish fossils. We found some other bone, which may be crocodilian. It's not as rich yet as we'd want it to be. This past trip in this last November, December, we could not get into the fossil horizon we wanted to. So unfortunately, we didn't get back towards where the good vertebrates were. But certainly the little bit of time we've had to collect here has allowed us to identify some really, really interesting fossil material. Over here on the side, we have a part of a catfish skull, really quite neat. We've also got some turtle bone right here that comes from podocnemids. Podocnemids are different than the geomytids and the tortoises and the soft shells we saw before. Tortoises, soft shells, geomytids are what we refer to as S-neck or straight neck turtles. Podocnemids are side neck. It's the way they retract their necks. You can see this guy pushing his neck to the side. When you scare them, they tuck their head in beneath their one arm, whereas the geomytids pull their neck back in more of an S shape, almost a snake-like fashion instead. We certainly do know them from Asia, but we don't know them from Indonesia. And so these are the first podocnemids from oceanic Southeast Asia, the first record of a pleurodire from oceanic Southeast Asia. Very, very exciting. And that's actually quite cool for a single day's worth of collecting. Going a little bit further up then, remember we talked about this before. This is our Tambak member over here, dominantly marginal marine to non-marine. That contains estuarine deposits and some delta front deposits. But for the most part, we're looking at soil horizons, coal marsh horizons, and channels with some intertidal flat successions preserved within them. Above this, we get into fully marine successions. And so above this, the entire succession is marine. This blue line right here, there it is the beach. At that point right there, if you're standing right here, that's the point in which the world is flooding. Above that becomes distal offshore into a deep marine deposits. This particular slide right here would probably occur right about at this horizon, but it occurred on an outcrop that's behind me in the photograph right here. We're seeing the right-hand photograph right there is a nice succession of the Pagat member. The Pagat member is our marine. Sorry, there's a typo right here. Instead of marginal marine, that should say fully marine right there. So in your minds, erase that marginal and make it fully marine. What we're looking at right here then are marine shales. If you were swimming out here, you would not be able to touch base. We're looking at 20 to 50 meters water depth in the succession off to the side right here. There's a horizon along the bottom right in here, which is, where's my pen? There it is, there we go. Along this bottom right in here, the orange bed right here, you can see the white dots in there. It's actually a fossiliferous bioclastic packstone to bioclastic grainstone. It's dominated by foraminifera and has lots of gastropods, some corals, some fossil crabs, etc. within those beds right in there. Above this is a flooding surface. So we deepen all of a sudden right here and then gradually shallow up into these interbedded deposits right in there. And then where the workers are standing right here, another flooding surface. And so in this Pagat member, what we're doing is a whole series of shallowing upward successions, but together stacked on top of each other, they actually comprise a deepening upward succession, if that makes sense. And so we have a deepening event, an abrupt deepening event, that gradually shallows. An abrupt deepening event that steps out further basinwards. So with every one of these flooding surfaces, we get deeper and deeper and deeper and deeper within the succession. So it's actually what I would refer to as a retrogradational or a transgressive succession, if you want. There we go. MFS standing for marine flooding surface in both those circumstances right there. Two different parasequence boundaries. Looking at our study area here, we are, again, deeper water than we were before. We can see our study area sitting right in there. And don't worry, I am getting towards the end of my talk right in here. I've got a few more slides to go through. But we're sitting offshore. We're in fully marine conditions right here. But I do want to take you through and show you a few of the fossiliferous successions. And so the individual fossils we're showing right here. The center bar shows the overall complete section in the the 2014 study area right in here. So we can see that overall, our proportion of grainstone, sandy bioclastic grainstone diminishes up section. You can see the images I have in here of different types of fossils. So we have scallop fossils and other types of clam fossils and gastropod fossils or snail fossils down there. We start to see these disc shapes. Those are some of my corals in there. Those are flat corals. We see crab fossils, and I'll show you some examples of those in a few seconds, with more diverse fossils in some of our upper beds. And higher up, we actually start to see some little horn coral type shapes. Really, really quite neat, quite unusual. That are actually quite characteristic of both offshore offshore Indonesia nowadays, as well as offshore Indonesia during the Eocene. Again, I'll just go through the photographs right in here. This photograph right here is this bed right in here. This photograph, oh no, I'm lying to you, sorry. This photograph right here and this photograph right here are part of the same bed. These are our uppermost bioclastic grainstone bed right in here. So that contact right there is that contact right in there. This is the looking down on top of that bedding plane, showing some of the larger benthic foraminifera right here, the really, really large ones, the centimeter scale ones. They get up to 2 or 3 centimeters across in this area. And on the left-hand side of the photograph, we see this nodular horizon right here. It's probably a crab burrow. It's occurring in this horizon over in here. And then vertical photograph right here showing the amazingly bioturbated sand beds in here. These are probably all arthropod, probably all crab burrows within these bioclastic sandy beds. Oop, and just jump forward. What do the fossils look like? Well, those are not fossils right there. Well, Russ is almost a fossil right there. He's getting older right there. It's Russ Shahan sitting with one of the workers. What I wanted to show right here are these carbonate beds, the bioclastic packstone, bioclastic grainstone beds that comprise foraminifera reefs. They're foraminifera reefs or reef mounds, if you will, with small solitary coral populations that are occurring in different areas. There's two of them, two reefs shown in this picture. This first one right here tapers out right here, comes top right here, bottom right there, and this lower one right here. It's a little bit lower in the section. This bedding plane right here just goes just a little bit below that one right there. And so we see these things right here offlapping with each other. It's one horizon that actually has numerous reefs at different levels within there, reef mounds in there. Jump forward, next slide, showing where those mounds are. If you can't see it yourself, I've got them drawn there in neon green. Here's what some of the fossils look like. You can see some of our large disc-shaped Cycloceras-shaped fossils right here. Cycloceras is quite a common coral in the study area. And again, lots of these Cycloceras on my hand right there, as well as a side view right here of some of the more horn coral, cone-shaped fossils. Really, really quite neat. You can see some of the foraminifera up in here, the large round discs. That's about 1.5 centimeters across right there. Lots of echinoid spines within these. These are amazingly diverse populations. On the right-hand side, we see a couple of crabs. So this is probably a portunid crab right in here. I'll show some better examples in a second. But what's cool about these two examples, sorry, are these crabs are actually articulated with the right arm and left arm preserved here. Another mud crab right in here with his right arm preserved in situ right in there, occurring within the shale successions. We've collected numerous examples of that. We've got at least 5 or 6 different taxa within this. Exciting, we actually have frog crabs. Frog crabs are really, really unusual in only preserved in a few parts of the world, but they're moderately common in the Eocene. So we've actually got frog crabs right here. This case right here, we're actually looking at Reninoides. It's an extinct genus of crab, of frog crab. They're long and narrow. This is probably one of our burrowers right here. These guys typically live in a burrowing lifestyle. This right here is a Tumidocarinid, probably something called Lobonodus. Again, you can see the articulated appendages on that crab right in here. We're looking at the top right here, the bottom right here. You can see how big this part of the crab is right here. I'll argue we're looking at a female right here, a small female right here. There's a centimeter scale for scale right in here, looking at it head on right here and butt on right here. Really quite cool. It's an extinct genus, probably new species for all of these things. Another example right here. Oh, sorry, just another example. Other things that we found in here are some vertebrate material. We found a few shark's teeth in these horizons. as well as this fossil right here, which is quite cool. It is the rostrum of a batoid, of a ray, a sawfish in here. So here's a modern one right here, taken from Wikipedia, shown right here. And this is actually a field shot right here I cut out of a slide we took on my phone camera. We haven't actually got good pictures yet because it hasn't been properly prepped. It actually has a number of the tooth spines off the side of it preserved. And so I'll make sure you guys see photographs of that once it's actually prepped out. But it's actually quite a cool find. So bringing things together, a lot of stuff we covered here today. And revisiting our questions about the questions, things we're interested in discovering. Well, the Paleogene terrestrial vertebrate fauna we have, it has distinct age and affinities. It's consistent with tectonic reconstructions that suggest a later Oligocene contact between the Sunda Shelf and Australia. There was time in between. We're looking at more of an Asian influence in our Eocene rocks than a Australian influence in our interesting rocks. But interestingly, there does seem to be Gondwanan influence as well. In terms of the faunal province, it's consistent with the pollen data that suggests dispersal of Gondwanan flores from India as it docked with South Asia in the Eocene. Now, we still got a poorly sampled fossil record, but these fossils right here are some of the very first vertebrates of Paleogene age that have been discovered in this part of the world, in oceanic Southeast Asia. And they're important for plate and for paleogeographic reconstructions. A lot more work to do. If anything, we've actually unveiled more questions than answered so far, but such is the nature of our work quite often. Now, in terms of the overall environments, it's important for us to recognize we're also looking solely at coastal faunas. We're not looking at the interior. We're not looking at land center faunas and floras. We're looking at coastal faunas. Everything we've got is down near the ocean. To date, every basin we've looked at exhibits trace and body fossils with marine influences. The pleunomorphous successions show marine influences. They show dinoflagellates and foraminiferal coatings. And so we're still looking at material that actually comes from down near the ocean. There's shore proximal terrigenous settings, brackish swamp, marsh, or fully marine shelf and carbonate ramp types of successions that are producing the fossils that we've analyzed. Okay, well, that was an awful lot of material to go through in a short period of time. I, of course, want to thank the mines that have actually allowed us in. Almost all of our study areas, with the exception of the Tanasira road cut quarry, occur on mine territory. The NIL mine in Sumatra, and of course the Hanneman pit in South Kalimantan. And we really appreciate the mine companies allowing us into these areas. We'd also like to, of course, thank the Getty money that Greg got when he was at Duke University, and of course National Geographic, who's funded all of the research that we've done in these areas. And so I'm done with that. I'm going to release do the stop share on the screen right now, and go back to you folks, and open it up for questions.
All right, thank you, Pak JP. Very interesting presentation on paleontology. That's why we have so many questions. Yeah. But due to limited time, perhaps you can just answer a few questions. I will pick up some questions. Yeah. First, maybe Pak Rudy Arif. Pak Rudy Arif, are you still here? Hello, Pak Rudy? Pak Rudy is not here.
Ada tuh, udah dibuka. Udah unmute Pak Rudy.
Pak Rudy, please ask your question by yourself, just one question at a time.
Bisa dibacakan saja, Pak.
Okay, if Pak Rudy is not willing to ask by himself, I will read the question. What is the specific fossil of fauna found in Sumatra Basin which is proven as the Paleogene fauna of Sumatra and still exists until now at the same shape?
Well, you know, all the fossils we found actually have modern representatives in Sumatra. and Kalimantan. There are still similar taxa of turtles. We're still working on the crocodiles, of course, but we think that probably these are related to some of the existing crocodilians. The Ziphidont crocs are probably unique. They don't occur in, as far as I'm aware, the Ziphidont crocs don't occur anywhere in the world anymore. Their lineages, I believe, are fully extinct. So they would be something that are no longer around. But the other crocodiles are probably related to some of the forms that we actually have down in Indonesia. I can see the list of questions right here on the Zoom chat, and I can answer a few if you want. I don't know if Frank Huffman's available. I see his question. So, would you like me to address the questions in the chat, or do we not have time?
There are many questions, so we have a limited time. So I will just pick it for you.
Okay.
The next question is come from Pak Andang. Pak Andang have some question, but I think Pak Andang can just ask one question this time. Please, Pak Andang, you can ask your question by yourself. Pak Andang?
Thank you for the very nice presentation, and there are all news from me. But I pushed a lot of questions over there, but later on will be answered with kind of detail. But I want to grab the big picture of it, especially the conclusion that you draw from the all of the work that's been done in Sumatra and Kalimantan, which say that especially the influence of Gondwana down from the south is not happening at the Eocene time in terms of a biotic over there. So it looks like it was happening after Oligocene time. How about the succession from, especially in Sumatra, you also got the Sawah Lunto formation over there. Did you see that kind of differences in terms of biotic from Sangkarewang to Sawah Lunto, or just a wild conclusion that it is happening after Oligocene?
I see what you're saying.
Biotic Gondwana and Laurasian.
Yeah, that's an interesting question, and I think right now we're not prepared to answer that yet.
Okay.
Yeah, it's tough with the data that we have. We're still working on this. This is very much ongoing research. We're still working on trying to understand the significance of the fossils. Many of the fossils are still in the lab being prepped out, and so until we actually know the species and know the lineages of the fossils we're dealing with, we're going to be uncertain in the answers to your questions right now. Certainly, these are important, and certainly the material that we have better data on right now is from the Sawalunto. Now, comparing the Sangkarawang and the Sawalunto is hard because the Sangkarawang fossils are occurring fully within a lacustrine succession. They're older and they're from a large lake, whereas the Sawalunto come from a coastal marginal marine to marginal lacustrine succession. They are younger. And of course, we're looking at a different fauna there. The fish we're looking at are things that are occurring in reeds and occurring in plants along a shoreline. We're seeing crocodilians and turtles that are certainly in there feeding on things. And of course, everything's disarticulated. We're not finding any full vertebrates in there. We're not prepared to actually differentiate sources of animals until we actually get the genus and the species of the animals themselves. That's where we'll actually be able to start to say clear things about migration routes and sources of the actual animals.
Okay, thank you.
Okay, the next question is very interesting. It's from Pak Agung Sedayu. Pak Agung Sedayu, you want to raise your question by yourself, or I just read it? Pak Agung Sedayu. Pak Agung. Pak Agung Sedayu. Okay. I will read
Yeah, I know I went a little bit late today because of the technical problems. So.
Okay, so here's Pak Agung study question. I am interested in your Proteaceae fossil. To my untrained ears, it look more of from of the genus Microsaurus. In Sumatra, the common Proteaceae genus is Helicea, which does not bear pinnately portate leaf like your fossil. The question is, if Proteaceae is good one certain plant group, do you suggest they arrive in Sumatra after the collision of Indian subcontinent?
And then it's the same answer as before.
Difficult,
yeah, we still need to spend more time. Once the fossils are prepped and once we can see the full fauna, we will have a better understanding of what the likely sources are. Like I said, we still have, at this point, early in the project, we still have more questions than answers. Yeah, we need to just finish describing the fossils first. Much of the material was collected in November and December of this past year. And of course, since the fossils were collected, they've all been in a lab and no one's worked on them. We've been stuck in COVID. No one's allowed to touch the fossils right now. So, yeah. So we have like everything in the world right now. We have to wait until until COVID goes away. So.
Okay, actually we have many questions, but because we have limited time, the last question maybe just for encourage new scientists. Some people asking this question, why you interesting with paleontology? What motivation you have for learn, and tip for us who want to learn paleontology and knowing about the fossil?
Because we all got where we are in some way or other. You know, paleontology to me is it's part of an extension on who we are. You know, we tend to separate sciences out really knife edge. That's anthropology. This is paleontology. But to me, it's all part and parcel. It's all related. And so I'm interested in my origins. I'm interested in how your ancestors and my ancestors were once all one people and have gone to different places. But that goes further back, because then I'm also interested in how did our people once be related to other primates? How do primates are related to other groups of animals? And so I'm interested in the connections that everything in this world has to everything else. And paleontology is how we actually understand those connections.
All right, thank you. I think because it's already almost to 11 time, so we will finish our talk today. Thank you once again your presentation, Pak GP. Maybe
one more question, can I?
Okay, yes. Okay, just one, yeah, please.
I will also just say, before you ask your question, I will say to the whole group that if anybody has questions and wants me to answer them, certainly Zaim or Jan or Azwan, Nabila, anybody can provide my email address, and I'm happy to actually answer questions. So.
Oh, we covered all of the question, and we will send you later.
Awesome. Good.
Okay,
that's good
this
idea,
is again not related to the question that I posted over there, that later on will be sent to you by the whoever from Geology ITV there to you. But this is about the conclusion that you made. It looks like you conclude that most of the fossil that you found over there, especially in the Paleogene time, and I especially now revert to the Eocene time, especially in the Sangkarewang and Tanjung Formation. You said that the most of the fossils are related to the area brackish or close or proximity to the marine, while all our understanding I'm from the oil and gas industry, we all understand that Sangkarewang is fully, a lacustrine deposit over there, or even talk about Gurami. Gurami is a freshwater freshwater fish, which we really like to eat now. So how do you view this as, I saw that you make some conclusion that it is all the area during the Paleogene time is kind of close to the proximity of the ocean or marine, but it's not really marine, but in transition, while in some places we really believe that it is restricted lacustrine deposit. And even we believe that in Tanjung Formation also, we also have some restricted lacustrine deposit rather than transition to marine. What do you think about that?
Well, first of all, the San Caroline Formation, I would argue, is fully lacustrine. There's no strong evidence anywhere in there of marine influences.
Okay.
We don't see marine influences until the Suolento, and then we actually see trace fossils, but we also see body fossils. The dinoflagellates, the foraminiferal coatings that come out during palynological work are indicative of brackish settings, of marginal marine settings. And so there's 2 or 3 different lines of evidence to suggest that for whatever reason, the sea invaded our basin temporarily in the Suolento time there. Same within the Tanjung. I'm not arguing the Tanjung is fully marine influenced, but there are horizons where we have marine influences.
Mm-hmm.
So maybe an estuary that snakes in, kilometers in from the ocean. We're looking at deposits that are proximal to that a marine influenced channel. Think about some of the rivers. I know here in North America, the Columbia River, we can trace marine influences in the Columbia River tens of kilometers, 50 kilometers, 80 kilometers upriver into the interior. So when I say proximal to a coast, I'm talking like that. Close enough that marine waters make it in periodically, but far enough away that we're actually still looking at terrestrial plants and terrestrial, So the point I would have, for me as a paleontologist, what I differentiate are what I refer to as lowland faunas and upland faunas, and the way they're the animals co-occur. And you know, of course, you know yourself. If you look at Indonesia nowadays, you would see a very different group of mammals and a very different group of reptiles down within 30 kilometers of the coast than high up in the mountains. Bandung has a very different fauna than Jakarta, the area near Jakarta there. So there's very different animals. And what we're seeing here is the trace fossil evidence, the body fossil evidence, and the lithological evidence is indicating that we're actually closer to the coast than further from the coast. Yeah.
Okay. Thank you. Okay, Pak Khairil. Silakan ditutup.
Hope that you satisfied with your question. Your answer. Okay. Last announcement before we close. Please, want to have a certificate, just fill the form that posted in the chat room. Don't forget to fill the form and send it to admin. Okay. Thank you, everybody, for your attention and
can
coming.
I short speak for?
Okay, but okay. Last talk before we close it. But Jaim, please.
Just a minute. I would like to thank to all of you, the attendees, for this seminar. It's a wonderful talk from GP. It's really wonderful. That's thank you so much, GP, for your time and your willingness to present this preliminary result of our research. Thank you also for Frank Hartman from Texas University, and also Pak Andang from Paris. It's really overseas webinar. That's here also there was for oil companies. That's Dr. Yarmanto here. I know well you. That's thank you so much. And of course, this is Sonny Trisunu, the boss for Arutmin before. So this the owner of Arutmin. Thank
wonderful.
you, Sonny. Yeah. And
hello.
thank you so much for
presentation.
Pak Khairil as moderator, Mika, Maria, Nadila, and of course Pak Yan, Pak Aswan, and Gus Harsario of Indonesian team during our research there. Again, thank you so much for your time, and maybe we will meet in another PaleoTalks. Thank you so much.
Foto bersama Pak, jangan lupa.
Thank you Pak Zain.
Foto
bersama
bersama.
dulu.
Oh, bersama. Oke.
Ya, foto.
Just a minute before you leave, we will take a photo together.
Good.
Admin, Mika, please.
Unmute me biar videonya keluar.
Bisa silahkan nyalakan dulu videonya. Yep.
Wah,
Ini
beberapa halaman ini.
Jam lagi.
Ada juga Dwijo. Ini Dwijo dulu salah satu tim ini. Terima kasih Dwijo, selamat bergabung.
Ada Dumex, makasih Dumex sudah hadir.
Oh ya, Dumex.
Dumex ngajar paleontologi di Pertamina.
GP, is it possible to have your material? Some audience want to have a copy, but if you don't mind, of course.
Nggak dijawab sama dia, Ril. Gua tanya lagi, Ril.
Oke.
Nggak jawab.
Halo, GB.
Ya udah.
Thank you,
Banyak yang unpublished ya.
Frank. Thank you so much.
Everybody.
Thank you everybody. Thank you GP.
Thanks
Frank.
for being here. Thanks JP.
Ya, terima
Good to see you, Mika.
Yeah, it's very great to
Terima
see
kasih,
you.
JP.
Great talk as usual.
Thank you.
Thank you very much.
We'll talk soon, Zaim.
Yes.
Good.
Thanks.
See you,
Yeah,
Aswan. See you, Jan.
Yeah, see you, GP.
I know Goose is up there.
Thank you, GP.
Presentation really good presentation. Amazing.
David, Duran again.
It is wonderful to see you all.
Even for us, wonderful to see you also.
Thanks a lot.
Terima kasih Pak Sony. Terima kasih.
Thanks, Frank.
Sony, makasih.
Oke,
bye.
Bantuannya
Mika,
di
mungkin chatnya bisa di copy
lapangan.
dulu, Mika.
Ya Pak.
I'll check out now too.
Chatnya di save dulu
Terima kasih, Pak
sebelum
Zaim.
di close.
Udah, Pak.
Udah ya.
Terima
Oh
kasih.
ya, jangan lupa juga terima kasih untuk Pak Dekan yang telah
Oh iya Pak Irwan.
Pak Irul, terima kasih.
sampai kelupaan untuk Pak Dekan.
Sama-sama.
I'll close the room now.
Okay.
So yeah, thanks for
berikutnya,
being with us, JP, and I will send you all the question that we have today.
Thank you.
Wonderful. Thank you, Mika.
Sure. All right.
Terima kasih.
Yep. See you.
See you.
Iya.
Terima kasih.
See you.